Welcome to another video from ultimatealgebra.com. In this video, we will be introducing ourselves to word problems. Specifically, we will familiarize ourselves with the implication of different words and expressions. Being able to translate the various expressions to math forms 90% of the requirement to be good in solving word problems. Let's look at the most common expression used, addition expression. The following expression implies addition. 1. Increase by. 2. More than. 3. Added to. 4. Sum. 5. Comparative words that denote more than. Longer, faster, taller, and so on. If we have 5 increased by 3, this is the same as 5 plus 3. If we have 2 more than 8, this is the same as 8 plus 2 or 2 plus 8. You can interchange numbers in addition. Subtraction expressions. The following expressions imply subtraction. 1. Decrease by. 2. Less than. 3. Taken from. 4. Subtracted from. 5. Difference. 6. Comparative words that denote less than. Smaller, shorter, slower, and so on. One important thing to know about subtraction expressions is the order matters. If we have 8 decreased by 5, this is 8 minus 5. This is straightforward. But if you have less than, the second number is written first, or we can say it's written backwards. So 8 less than 5 is 5 minus 8. Notice we had the 5 first. We say that for addition, order doesn't matter. For subtraction, if you have less than, subtracted from, taken from, or any of the comparative words that denote less than, we write the second number first. He is 2 years younger than X. This will be X minus 2. Notice, we wrote the X first and the 2 second. Multiplication expressions. The following implies multiplication. 1. Multiply by. 2. Times. 3. Twice, thrice, double, triple, and so on. 4. Product. So, if we have 2 multiplied by X, that will be 2 times X, which is simply 2X. Division expressions. The following implies division. 1. Divided by. 2. Quotient. 3. Shared equally. 4. Per. If we have 20 shared equally among 4 boys, this will mean 20 divided by 4. Next, we look at expressions that implies equal to. 1. Is. 2. Was. 3. Gives. 4. Becomes. 5. Equals. So, if we have 2 plus 3 is 5, it's the same as this. The is meant equal to. Finally, to solve most word problems, you have to identify your unknown value and represent the unknown value by X, or any letter you prefer. Example, if we say number minus 4, we do not know that number, so we can represent it by X. So we have X minus 4. We will end this video here. Please download the expression sheet below this video. You have to be familiar with these expressions. In the next video, we will be looking at tons of examples. Have a great day. Goodbye. Welcome to another video from ultimatealgebra.com. We are still looking at expressions and word problems. We will be looking at some examples. Hope you have printed out the expression sheet. You have to know all of it. Translate the following expression. Number 1, 2 increased by 4. We know that increased by means addition, so this will be 2 plus 4. Number 2, twice a number is 4. We see 3 key words. We know that twice means multiplication, exactly 2 times. We know that a number is our unknown, so we can represent it by X. Finally, we have is, which we know means equal to. We can write this as 2 times X equals 4. 2 times X is the same as 2X, so we have 2X equals 4. Number 3. 7 more than 3 times a number was 20. We have 7. More than means additions, so we have plus. A number is our unknown. We can represent it by X. So 3 times a number will be 3 multiplied by X, which is 3x. Finally, we have was, which means equals. So we have equals 20. Our unknown doesn't always have to be represented by a number. Example, 3 times Rachel's age is 5. Here the unknown is Rachel's age, so we can represent it by x. This will be 3x equals 5. If we have $10 subtracted from Joel's money becomes $30. Here we have becomes. We know that means equals. So we have equals 30. Next, Joel's money is our unknown, so we represent it by x. Remember, we learned in the previous video that when you have subtracted from, you will write the second thing first. So 10 subtracted from Joel's money is x minus 10. Important use of parentheses. Before we end this video, we want to look carefully at these 4 keywords: sum, difference, product, and quotient. We already know that sums means addition, difference means subtraction, product means multiplication, and quotient means division. But these terms denote a group, and it is necessary to put them in parentheses. Then work from there. Example, the sum of 2 and x is 12. So here we can write it this way. Notice that and is what is between the two numbers that we are adding. Let's look at these two statements. 4 times 3 plus 5, and 4 times the sum of 3 and 5. We notice that in both cases we have two operations. We have times, which means multiplication. We have plus for the first statement and sum for the second statement, both meaning addition. These statements does not mean the same thing and will nor yield the same results. The first one is straightforward. 4 times 3 plus 5. From our order of operations, we do our multiplication first, then our addition. We multiply the 4 and the 3 to get 12. Then we add the 5 to get 17. Let's look at the second one. Again, we have 4 times, but here we have the sum of 3 and 5. We said we put this in parentheses, so we have this. From our order of operations, we know that we have to do parentheses first. So here we will add the 3 and 5 to get 8. Then we will multiply 4 by 8. This will give us 32. If we had not put it in parentheses, we would have solved it as 4 times 3 plus 5, and we would have had it wrong. I hope this example helps you understand why we are making a big deal out of using parentheses for sum, difference, product, and quotient. We will end this video here. Please go over this video and try your hands-on as many examples as you can. There will be no reason to continue to the next lesson if you haven't mastered this one. Have a great day. Goodbye. Welcome to another video from ultimatealgebra.com. In the previous lessons, we learned how to translate algebraic expressions. In this video, we will use that to solve actual word problems. Let's take our first example. Leslie's age is 3 years more than twice Victor's age. If the sum of their ages is 48, what will Leslie's age and Victor's age be? The first thing I like to do when solving any word problem of this nature is to identify my subject or thing the question is about and represent them with letters. Here we are looking at Leslie's age and Victor's age. We can represent Leslie's age by L and represent Victor's age by V. Now, let's go sentence by sentence and translate the word problem into math. Leslie's age, which we represent by L, is, we know that is means equals, 3 years more than. We know more than means addition. Twice Victor's age means 2 times Victor's age. We represented Victor's age with V, so this can be written as 2V. Next, we are told that the sum of their ages is 48. We know that sum is addition. We are adding their ages, so we have L plus V is 48, which is the same as equals 48. Now we've been able to set up the word problem. We are going to use substitution to solve it. I will label this equation 1 and label this equation 2. Since L is 3 plus 2V, we can substitute the L in equation 2 with 3 plus 2V. We have 3 plus 2V plus V equals 48. We solve for V. We have 3v equals 48 minus 3. V equals 15. So here we have Victor's age as 15 years. But the question wants us to find Leslie's age also. To find Leslie's age, we can substitute V equals 15 in equation 1. We have L equals 3 plus 2 times 15. We solve for L to get 33. Leslie's age is therefore 33. We can see that there are two things needed to solve this question, and you have to be a master in both. 1. You should be able to translate the word problem. 2. You should be able to solve the equation, in this case, the simultaneous equation. We will end this video and look at more examples in subsequent videos. Have a great day. Goodbye. Welcome to another video from ultimatealgebra.com. We are still looking at word problems. Here we want to look at implied meaning. You are not always going to get all word problems having a direct translation to math. Let's solve an example to explain it. A farmer sold a horse and a cow for $210. He sold the horse for 4 times the price of the cow. How much did he get for each? Again, I start by identifying the things the question is about. It's about the price of a horse and the price of a cow. I will represent the price of the cow by C and represent the price of the horse by H. Now, let's read the question and translate it. A farmer sold a horse and a cow for $210. This statement does not follow any of the things we learned about the direct translations. We can, however, notice that this means the price of the horse plus the price of the cow equals 210. We call this our equation 1. He sold the horse for 4 times the price of the cow. Here again, apart from the 4 times, nothing follows the direct translation we've been learning. But we can see that this statement has the same meaning as the price of the horse is 4 times the price of the cow. So we can say that H equals 4C. This will be our equation 2. So we are done with our setting up. Next, we want to use substitution to solve the equation. We can replace the H in equation 1 by 4C. Now we have 4C plus C equals 210. We solve for C. We have 5C equals 210. C is therefore 42. Next, we can substitute 42 for C into equation 1 or 2 and solve for H. I choose equation 2. We have H equals 4 times 42. We multiply to get H equals 168. So the farmer sold the horse for $168 and the cow for $42. To be able to solve this question, you need to understand the implied meaning and translate it to mathematics. Then, as usual, solve the resulting equation. In this case, simultaneous equation. We will end this video here. Have a great day. Goodbye.